Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Dynatrace.
But before we begin, let me inform you few things about us. DevOps School is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
Okay, so before understanding about the Dynatrace, let's understand the little bit of monitoring world and observability world. So some of the time we perform some of the common mistakes and which states like, okay, we are running things on AWS, Azure, Google Cloud. We have some of the stats from the cloud itself. So yes, we don't need any dedicated monitoring solutions as such. That is pretty much common mistakes. Many projects, they do that. One of the big mistakes which we do most of the time in the world of monitoring is like our software is number one in the market, generating lots of money, and then we don't need to set up a complicated monitoring. The things we are market leader in this category, and this is one of the big mistake we usually the projects is considering. Now, third things very often people say like we don't have a time for that. We are busy in the coding, we are busy in the testing, we are busy in the release, we are busy in the marketing and all everything. We don't have a time to set up a monitoring, and that's the biggest mistake, right? So suddenly the system failed and some hacking has happened, some hacking has happened, and then we need help. Okay, and we realize like, okay, we have performed a huge mistake actually. Management is also asking what you have you gotten into us. So that's where the monitoring is coming into the place, right? Monitoring is the systematic process of collecting, analyzing, and using information to track a program's progress towards reaching its objective and to guide management decisions. So why monitoring? So some of the advantage which we have is like we want to analyze the long-term trends. We want to compare things over the over the time. For example, the speed, CPU, RAM. You want to compare utilizations and all stuff like that. Disk utilizations. You want to network utilizations and stuff like that. You want to have alerting, so something which is goes beyond the threshold. We need on that also alerting. Building a dashboard. Building a dashboard means we want to have visualizations for what's going on our infrastructure and production environment, pre-production environment, and so on. And also on top of that, we want to conduct ad hoc retrospective analysis, i.e. debugging, for the anything goes off on whatever it is. So for example, latency is just shot up, so you want to troubleshoot why it has shot up. So these are the primary reasons why we do the monitoring. Now, if you look at this, what are the primary uses of monitoring slash observability data? So yes, 93% of the time we set up a monitoring to alert on issues. Issues can be anything: server issues, network issues, system issues, process issues, and different things. We also want to diagnose, so we set up a monitoring. We want to track SLAs and SLO, service level agreement and service level objective. We want to track it, whether we are able to achieve that SLOs which is committed to the client or not. And also we want to identify area of optimizations and to ensure reliable releases. So yeah, these are the primary reasons why we are using we are doing monitoring. So when you get into the monitoring plan, then you'll have some of the basic questions like what to monitor, how to monitor, who will collect the data, and when to monitor. So these are the primary questions you must be having in your mind. What to monitor means which objective does your projects have? how to monitor, define indicators and sources of verifications, SOPs, and such as interview studies, test cases, and stuff like that. Who will collect the data? That means some sort of agent, or for the monitoring, some disseminate responsibility for monitoring, and when to monitor, when you collect the data and the results. These are the primary things you ask for it during the monitoring plan. Now, when it comes to what to monitor, right? So typically, I think we all are comfortable with it. Like we want to monitor like a system level checks. What system level checks? Like a CPU, memory, disk, load, network. We also want to monitor the process level checks and application level checks. That means this process running or not, this process threading information, memory utilization of that particular process and stuff like that. Also, we want to check that message level checks like active client, number of requests, number of response code, 200, 300, 400, 500, and all. Connect failures. Also, we do nowadays API, the world of API. So we do the check of the API level checks also, like API call, API error, and stuff like that. So yes, these are the things which we want to monitor. Again, we want to monitor for availability of the applications. We want to monitor things for the security monitoring. We do the data validations. We want to monitor what to monitor, the performance monitoring. We do the data validations. We do that, and integration monitoring. We do that. So availability means whether the system is up and running or not. Security monitoring means the system is secured or not. Performance monitoring, data validation, integration monitoring, and so on. So yes, overall, yes, what to monitor? We monitor application, services, operating system, network, and all these system produce the metric data, and that is what monitoring system capture that all these matrices, store it at some place, and from there we do the visualizations like alerting dashboard and so on. Yes, this is a monitoring. So now if you want to set up a monitoring, what are the flow for it? So yes, you have to collect the information, share the information, review in meetings, implement changes, review indicator to monitoring. And nowadays also we have one process which is called continuous monitoring. So in which define the what you want to monitor continuously, establish, implement, analyze and report, respond, review and update. So these are the things we do, and we used to do from last so many years. Some of the benefits which we have is smart replacement, recover revenue, assess availability, improve workforce, decrease planned maintenance, Internet of Things, decrease service loss, lower risk. These are the some of the advantage. But monitoring is very hard. And why it is hard? Because of we have lots of data sources nowadays. Lots of data sources. Remember that monitoring is not something we are doing today. We've been doing monitoring from last 20 years, 30 years. And we've been having the lots of data sources. And that's the reason one of the reasons like monitoring is hard. Look at this here, that your applications can be accessible from the different people, different devices, different ISPs, different web server, different app server, different database servers, and the response time is for a few people is 300 milliseconds, and for a few people 1.5 seconds. You need to know what causing the response time is of 1.5 seconds, because one person is happy from the same setup, one person is not happy from the same setup. So what is causing this such a huge response time? Whether it's a problem with the device, whether it's a problem with the ISP, whether it's a problem with the data center, whether it's a problem with the network, whether there's a problem with the browser, whether it's a problem with the app server, web server, load balancers, database server, third-party gateways, where is the problems? So the end user is getting the response time in 1.5 second, and why this he or she is getting that response time. So yes, the answering. So these are the reasons we are setting the monitoring. We were setting the monitoring, which we've been doing from last 20 years. So primarily we put the monitoring into two buckets. One is white box monitoring, and another one is black box monitoring. So very thin difference which we have here. So white box monitoring is the monitoring of applications running on a server. Okay, so there's an application running in a server, and using so if you set up a monitoring to monitor that application, that is white box monitoring. So monitoring based on the metrics exposed by internal of the systems. Are you able to hear me? Are you able to hear me?
Yes.
Okay, great, great.
I'm following you. Yeah.
Oh yeah, so I just lost my power, so but yeah, backup internet is there, so I was just curious whether you are able to hear me or not. Yeah,
So
so
this
white box
reminds.
monitoring.
Okay. Yeah.
Yeah. So white box monitoring is the monitoring of application running on a server. That means there's one application running on a server and you are monitoring that application. That's called white box monitoring. So monitoring based on the matrices exposed by internal of the systems, including logs, interfaces like the JVM, profiling interfaces or HTTP handler that emits internal statistics. So you are getting the internal statistics of the systems, applications, and the services. That's called white box monitoring. But what is a black box monitoring? So black box monitoring basically refers to the monitoring of the servers with a focus on areas such as disk space, CPU uses, memory uses, load averages, etc. So this basically testing external visual behavior as a user would see. These are what most in the industry would deem as a standard system matrices to monitor. So yes, we have black box monitoring, internal data you get it, white box monitoring, internal data you get it from the applications, and black box monitoring, a standard system matrices you get it from through that. Look at this here, the difference between white box monitoring versus black box monitoring. So here, if you see that black box monitoring, basically, here you have HTTP error, HTTP server error. That means from the external services. So restricted to external services behavior, such as paying HTTP and so on. In white box monitoring, you are getting basically request processing time, request error total. So if in order to set up a white box monitoring, you have to monitor the Apache internal. But here, in order to set up the black box monitoring, you just have to have a network ping or HTTP at a high level and stuff like that. So yeah, this is the black box, white box. Now, which are the tools for the white box monitoring? So Prometheus is there, Zabbix is there, Neuralink there, AppDynamics is there, and Dynatrace is there. What are the tools for the black box monitoring? So these are the
Excuse me.
popular. So
Yeah.
yeah,
So if you go back one step, the white box monitoring is okay. No, the white box monitoring, you mentioned some tools for it, which is Prometheus.
yeah.
Okay, yeah. Okay, Neuralink. Okay. Okay, Dynatrace is there.
Yeah. So Dynatrace is also acting in a backdrop also, by the way. So both is supporting. Okay. So you can get the high level information, you can get
Yeah.
the internal information also both.
So Dynatrace supports both white box and black box, right?
That's correct. Yeah.
Then but Prometheus only supports white box.
Yeah.
So what about Grafana? You know of Grafana?
Grafana also. So Grafana basically it's a company name and they have a multiple products actually. So Grafana dashboard we have, Graphite we have, Loki they have. So many tools we have. So
So that
Grafana
is
is also, it's
okay.
also both actually, black box and white box both. APM
Okay.
they do have. Yeah. Okay. So now how do you implement that? Simple. If you want to implement that monitoring, basically you have to, measurement. You have to set the measurement and collect the collections of the measurement. Then do, that collections we stored in the storage database, and then using that you can analyze and computations. You can set up alerts and visualization like a dashboard and all. So these are the phases which we do in order to set up any monitoring. Now, now when you set up a monitoring, basically, you should address the two questions: what's broken and why. So what's broken indicates a symptom, and why indicates a possibility intermediate causes. So these are the two answers. If you're getting it, that means your monitoring is perfect. So now, if you look at the system versus cause, so here I'm serving HTTP 500s and 404s. So what could be the cause? So cause means database servers are refusing connection. So one way you get the symptoms, another way you got a cause. My responses are slow. What could be the reason? It could be CPU, it could be network, it could be RAM, it could be anything. Okay, so there's something which you call a system and something which you call it a cause. So yes, if you want to set up monitoring, these two answers you should be having it. What's broken and why it's broken. So these are the important things. Now there is a nowadays from last few years, I think 2 years, we are using also one signal called golden signals. Okay, so no matter which tool you go for it, you will see that these golden signals for it, and in which what we do, so we set up a monitoring based on the latency, traffic, errors, and saturations. Okay, this is called golden signals. 4 rules of golden signals. Are you monitoring latency? Are you monitoring traffic? Are you monitoring the errors which you got it? And are you monitoring saturation? So this is we have a golden alerts also, but this is the slides which we have is a golden signals. So yeah, latency means amount of time to service a request, slow feedback, and stuff like that. Traffic means number of HTTP requests, session transactions per second, and so on. Error rate, rate of failed request and stuff like that. Under the error. And saturation means your resources, how much is being utilized, like CPU, RAM, and stuff like that. So these are the things which we call golden signals. And nowadays we are using this one a lot. When you go for the setting up alerts, you will be called like, okay, let's set up a golden signal. That means alerts for latency, alert for traffic, alerts for errors, alerts for saturations. Okay, so yeah, latency. What is the latency? What is traffic? What is errors? What is saturations? Probably we can understand because we've been in this industry for a long time. We are, practicing all these things. So yeah, again, those if you are interested in to read more about what is latency, traffic, errors, and saturation, we'll get into the upcoming sessions and we'll discuss. Anyways, we are going to work on the same. So yeah, monitoring means process of collecting data from the system. You can have a historical view, different types of matrices are there. XML data, you have it from the monitoring. Monitoring will ensure the availability, resource utilization, and performance check. Okay, cloud native monitoring like CNC of like a Docker and Kubernetes container works. Yes, because of resources are volatile, lots of component, a need for service discovery, integration with infrastructure. That's a challenge which we have with the monitoring in the today's world. So now metrics has come from the purpose monitor your goals. So what exactly that's so this is the ladder of monitoring. Okay, and start from the 0 to 1, 2, 3, 4, 5, 6, 7. So these are the total 8 ladders you have. Okay, so here starting with ignorance, that means you don't know what's going on with your system, and then you set up, you want to know, you know whether your systems are available. You may have alerts availability, you want to do the alert, you want to collect the logs, forensic is possible. That's a step number 2. Third, aggregation, you aggregate and process data in a central place, correlation is possible. Analysis, you actually analyze that and the aggregated and correlated data, use it to the fix issues. Learnings, root cause analysis, run book, run deck, whatever you want to say, something fixes, anti-fragile, still responsive, and bring the automation in place to remediate that issues, whatever you are getting on a repetitive manner. And proactivity means, yeah, based on the 0 to 6, you can forecast the stuff. That's called proactivity. Okay, so active strengthening by attacking production system, and that's called chaos engineering. So these are the monitoring ladder which we have. Okay, so these are the monitoring tools which we have discussed: Prometheus, Graphite, InfluxDB, Open Nagios, OpenTSDB, Nagios, Jagax, Isinga, and so on, so much. But you know what? Monitoring is dead. Yes. So I was just introducing you the monitoring, but the monitoring is dead. And nowadays we are not using a keyword that's called monitoring, but we are using a keyword which is called observability. Okay. So yes, I'm going to introduce you what is observability. So monitoring, the one which we were doing from last so many years, basically is the basic component in their reliability pyramid and enable incident response and postmortem. So you see that you do the monitoring, you get an incident, do the postmortem root cause analysis, and based on that, you do the testing plus lead procedures, capacity planning, development, and product. So here, if you see that all these things you do that, and it's a most basic component in the reliability pyramid. So what to do? So monitoring is dead. Yes, long live observability. So monitoring tells you whether the system is working, whereas observability let you ask why is isn't working. There's a difference here. See here, observability means assembling all fragments from logs, monitoring tools, and organize them in such a way which gives actionable knowledge of the whole environment, thus creating an insight. We used to do monitoring. Once upon a time, there was a monitoring, but observability is a superset of monitoring. It provides not only high-level overviews of the system health, but also highly granular insight into implicit failure modes of the system. That means monitoring will give you the high-level information, but observability will give you highly granular insight into the implicit failure mode of the system. In addition, an observable system furnishes ample context about its inner working, unlocking the ability to uncover deeper systematic issues. But monitoring, on the other hand, is the best suited to report the overall health of the system and derive the alerts. So if you look at this here, these visualizations, you see that monitoring means you are checking overview and alerting you have, whereas observability is which including debugging, profiling, dependency analysis, and anticipating the futures also. Monitoring is proactive, whereas observability is reactive. Okay, so what to do in order to do the proper to set up observability? So yes, you have to work on the testing, you have to work on the monitoring, and combine the best effort verification of the correctness, monitoring predictable failures, and combine these two together, and whereas you can come up with the best efforts simulation of the failure modes. That is called observability. So monitoring system should address two questions: what's broken and why it's broken, whereas observability covers the larger scope. Monitoring is mainly used in terms of metrics monitoring. So in summary, observability is a property of the system and monitoring is an activity we perform on a system. So look at this here. This is a hierarchy of the monitoring observability. So in order to set up observability, you have to process everything, the data, matrices, events, and logs of the past, present, and predictions, future. So look at this here from the slower to faster. So tracing and logging, this is a kind of matrix which is done, which you get it, which is has happened in the past. So that has to be diagnosed. Again, some of the metrics you get it, which is happening in the present. For example, CPU, RAM, disk space uses. The live you may see on the dashboard. It's a present information. But from the tracing and logging and the matrices, you may get some stats and signal, which is you may detect, and using that you can predict the future. That is called observability. So yes, to summarize, observability gain understanding actively, whereas monitoring consume information passively. Observability asks a question based on the hypothesis, whereas monitoring asks a question based on the dashboard. Observability built on tame dynamic environment while changing complexity. Dynamic environment means like Kubernetes, Docker, and all this keep changing. You don't have a fixed environments. 10 pods got disappeared. You get a new 10 pods actually in Kubernetes. But monitoring primarily is built to maintain static environment with a little variation. So that means if you want to monitor the Kubernetes like a dynamic environment, it's very hard to do that. Observability preferred by developers of systems with the variability and unknown permutations with the algorithm. Monitoring we use by developers for the system with a little change and known permutations. So yes, we are trying to understand observability versus monitoring. So yep, observability focus on the metrics, traces, and logs everything, whereas monitoring focus on the availability, performance, and capacity plan. Together, you have to combine this. So yes, telemetry. So now the question is, how do we do this observability setup? How do we set up the observability? And there is a one keyword which we call it a telemetry. So telemetry is a collections of measurement or other data at a remote point and their automatic transmissions to receiving equipment for monitoring. The word is derived from the Greek root tele means remote and metro means measure. Telemetry. So what are the telemetry we have? In short, we can call it a MELT also. So four essential telemetry data types, which includes metrics, events, logs, and traces. That means if you want to set up observability, you need to gather matrices, you need to gather events, you need to gather logs, and you need to gather traces. Not only gather the matrices, events, logs, and traces, you need to analyze. You need to analyze this, you need to tokenize this, you need to filterize this, you have to aggregate and create some sort of meaningful data out of it. That's called observability. So yep, if you want to set up observability, you have to have a metrics in places in your system, traces and logs, everything you should be having at one place, so you can set up observability. So you can set up observability. So look at this here, how to achieve observability. So traces, metrics, logs, traces which talk about the relationship between the events, matrices, measurement of an event, logs, which is human readable events. The example of the traces is application component involved during a request with an error. Examples for matrices throughout throughput, error rate, request duration. Example for the logs, I think we understand application log, system log, event log, process log, network logs, and so on. The system startup output, processes output, and etc. So observability is equal to logging, monitoring, tracing, and visualization. So all things coming together and calling observability. So if you look at this here again, differentiating factors. So yes, monitoring will help you in terms of setting up the availability. Is my system available? Whereas observability will ask a question, how long is my system up? Monitoring in terms of performance will tell you, is my system healthy? Whereas observability will ask the question, what is my system doing? Monitoring in terms of fault management, when and where did it occur? But observability let you ask the questions, why did it occur? Recovery is my system backup, and here observability lets you ask, what can I do to prevent the issues from the recurring altogether? So yeah, this is the things. So these are the types of data that systems should produce to be observable. So yes, if you want to set up observability, remember the MELT for M for metrics, E for events, L for logs, T for traces. So yes, your system should generate a MELT information. That means the system should generate information which should do the health check, matrices, log entries, and distributed request or end-to-end tracing. So that four types of information should be producing to make the system observable. Now the metrics, I think we all understand that what is metrics, because we've been, doing the monitoring from last so many years. So we understand the metrics. Metrics represent the data in your system. Monitoring is the process of collecting, aggregating, analyzing those values to improve awareness of your component characteristics and behavior. Metrics capture a value pertaining to your system at a specific point in time. For example, number of users, CPU, RAM at certain time. Therefore, metrics are usually collected once per second or one per minute or at another regular interval to monitor system at over time. So these are the different kind of metrics you'll see: work metrics, resource metrics, event metrics, and so on. So work metrics mean throughput, success rate, errors, performance. Resource metrics mean utilization, saturation, error, availability. Event metrics means code changes, alerts, scaling events, and so on. So yes, work metrics, I think I'll just, at a high level, I'll discuss, because work metrics, you can see the throughput and success, error, performance, and so on. Okay, so I think there's some questions from you, right? I could not hear your questions. Am I audible to you? Are you able to hear me? Am I audible? Am I audible, by the way? Okay, I cannot hear you. So let me pause this session.
The
This
slide
conference
before
will
the
now be
last slide.
recorded.
Yeah, please go ahead.
Yeah, because I didn't see melt, not this one. You know, the slide before the slide, the last slide.
This one. Are you able to see my screen?
Yeah, it was the last explanation you made, the one previous to that one. It was showing something else, but you mentioned melt, so I could not correlate. You know,
This one?
not this, not this. Where is the last slide we were talking? You were discussing just now.
This one?
This is the last. Okay, go back one step. Go back one step. No, no, go. You fast. For one step forward. 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 One step forward. It's okay.
Yeah, you
Uh,
can check it later. Yeah.
yeah. It wasn't melt. It wasn't saying melt, but I think maybe you were just calling in. You were just mentioning melt, but that wasn't what the acronyms were
Yeah.
on that
Yeah.
slide. But it's fine. Yeah.
So yes, there are different kinds of matrices we have: work matrices, resource matrices, events matrices, and all. So yep, because we've been doing the monitoring from last so many years, we understand what is the throughput, success, error, performance, utilization, saturation, errors, availability, and so on. So yes, these are the matrices we are going to gather. So we are going to get the throughput, success, error metrics, performance metrics. We have, and some of these examples you can see here. Example of work metrics like throughput, success, errors, and performance. So when you say throughput, request per second, or success, percentage of responses that has a 2x since last measurement, or error, percentage of response that are 5x since the last measurement, or performance, the percentile, and sometimes also we call it this one is latency. Yeah. So yes, these are some of the examples. Resource metrics, which is including utilization, saturations, errors, availability. So if you look at this, disk, memory, and stuff like that is coming under the resource metrics. These matrices come from the resources of your system. Events, so such as like event log, you might have seen it in the Windows. Some events you can also consider like alerts has happened, or maybe changes in the internal code releases, builds, or build failures. So that also is a metrics. So some of the examples you can see that uh, some pull request, build request, stuff like that is easy. And logs. Okay, so permanent record of events, provide an audit trail, usually human readable, and so. So this is the example of logs you can see on X3. So traces means the you know the request. When you do to an application, you get a response, and that request travels throughout these multiple systems like a DNS server, load balancer, different network, different microservices, a web server, app server, database server, external services, payment gateway. So this whole traces has to be also monitored. So yeah, it's a specialized form of logging, provide low level information, allow event reproduction, usually not human readable. And distributed tracings also we need to gather to make the system observable. So this is some of the distributed tracing model. I'll just skip it. What is the difference between logging and distributed tracing? I think more or less we understand. Logging shows the state from the system's point of view, whereas the distributed tracing shows the state from the user action point of view. You understand this? So logging shows event and their meanings, whereas distributed tracing shows execution path and the performances. Logging helps with the system administration. Tracing helps with the software debugging. Logging readable by humans, processed by and tracing processed by specialized software. Okay, and we do also with the debugging with the logs and traces in a distributed environment. So yes, conclusion. Let me tell you, monitoring is dead. Monitoring is dead. What we should do, we should set up observability. So how to set up observability? So you need to capture melt data, melt for different kind of matrices, events, logs, and traces. Everything we should, capture. We should capture the business transactions, microservices call, user interactions, service-oriented architecture calls, batch jobs, file transfers, different types of data you will have in the observability, like a real-time and comprehensive instrumentation data, performance metrics, throughput metrics, error counts, log, dependency maps, and traces. And on that, you need to analyze this. You need to set up an AI analytics, AI-based hard cardinality, topology, and dependency analytics, baselining analytics, exception analysis, based root cause analysis. And then you should bring at the end of it, you should bring some business benefit, because we are going to spend so much of time and energy for the same work. So yes, it should help us in terms of business benefits. So improved online and improved online, improved businesses and service quality, performances, technical ability. So yes, we are here to set up observability, not monitoring. Monitoring, if you want to set up, you can use Prometheus, you can use Nagios, but when you want to do more than monitoring, then we have to set up the. Are you understand?
So yes, I understand. Thank you so much. So like how microservices call you have in monitoring. So how do you with the observability those microservices, how do you I believe those would fall under um like
Service discovery.
throughput metrics or what?
Service discovery we have. So if you look at this monitoring with the microservices and the
Yeah.
platform, nowadays we have a microservices with the automated registry. So
So what
we do.
so what does that fall under types of observability under observability? Because you said monitored, okay, everything here is under observability.
Yeah,
So
everything. It
you
should,
said monitoring is dead, right? But you
yes,
you have monitoring under observability here, right? Which is
yes,
part
yes.
of what's okay. Okay, that's the
So
microservice.
monitoring is a subset of observability.
Okay, cool, thanks.
So now the question is also, yeah, monitoring was also hard. So Nagios and Prometheus and tools like that, it solved it. But observability is also hard, because you look at this evolution of the computing. So earlier, you remember that we were running the system, I mean, applications in legacy hardwares like desktop and so on, servers. Slowly we migrated to cloud, then hybrid. And nowadays, from last few years, we are running application in containers. And containers are not permanent, it's not persistent, cloud is persistent. You create a few VMs and it will be there, but the containers are not persistent. So yes, you are running application in the containers. If you look at this, architecture also has changed. So earlier we were doing the following the monolithic architecture. Monolithic architecture means all the component of the software will be in one server. So monitoring is very easy for us. But over the period of time, we have migrated from the migrated from the monolithic to service oriented and then microservices. And now we have too many microservices, too many database, too many calls and registries, discovery, service discovery, and so many things which we have. So architecture also has evolved and created a complexity to set up observability. Look at this, a lot of calls from the one service to perform one transactions. You probably do the 20 traces. For example, login, registration, browsing, search, search the catalog, payment gateway, this, that, and so much of things. So to perform one transaction, you probably traveling towards 20 microservices, different internal services, external services, and so on. So it's very complicated to set up observability. Look at this here. He has some microservices, multiple database, multiple call, multiple API gateway, different way of communications, database layer, data access layer, business logic layer, API gateway layer, user interface layer. So just to run one applications now, we have so many components actually, and monitoring was difficult at the time for this. But again, you want to do much more observability, and you want to monitor everything. Too many microservices, too many calls. Now it's very difficult to visualize using some traditional tools. So you need some tools out of the box. Yes, you need some tools out of the box. So now the question is, which systems, which tool, which platform, which framework will help us to set up observability? Because these are so much of complexity in the environment and productions and stuff like that. So what do we do in this case? So yes, our goal, our objective is to find out whether my application is available, is it up? Whether my application is it slow, performance issues. I want to know whether my application is reliable, is it broken? I want to know my application availability, performance, reliability. I want to know network availability, network performance, network reliability. I would like to know server availability, server performance, server reliability. In simple way, my server is up or is it up? Is it slow? Is it broken? My network is up, slow, broken. My application is up, slow, and broken. And I would like to know complete information. And I need to have some systems which can help us to gather the complete information, complete melt matrices at one place in a microservices world, in the container world, right? Which system will help us? Which system? So these are the solutions which we have. So Datadog is very one of the market leader. New Relic we have, Splunk we have, Elastic we have.
So Datadog top?
It's not top. I would say all are popular here today. So Datadog is one of them. New Relic, Splunk, Elastic, App Dynamics, Dynatrace, and Grafana. Let me tell you, it's very difficult to get the real data, the real number of customers from each of these companies. So what are the you know that like large company, hundreds of projects, and different projects in one company you may be using everything. You never know actually. Depends on how which team and what their goals are. Correct? So these are the systems which will help us for setting up the observability, and you can pick up any tools in this and it will help you. So Grafana is earlier it was known as, I'll tell you, Grafana it was known as a dashboarding solutions, but now it's in everything. Dynatrace earlier it was into infrastructure monitoring, now it's in everything. App Dynamics was into performance monitoring, now it's in everything. Elastic was earlier into the log analysis, now it's everything. It's into everything. Splunk was into log analysis, now it's in everything. New Relic was into the APMs, now it's in everything. And Datadog was in infra cloud monitoring, now it's in everything. So yes, they have from last few years, if you look at this, they have transformed themselves to serve the complete, to give you the complete features of observability. And using these solutions, you can do the infrastructure monitoring, you can do the performance monitoring, you can do the log monitoring, you can do the synthetic monitoring, you can do the wrong monitoring, you can do the network monitoring, security monitoring, everything you can do that. You can store the data, and on top of that, you can do the analysis, alerting, reportings, SLAs and SLOs tracking, and everything. Getting my points?
Yes.
Yeah. So this is observability.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.
Hello everyone. If you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc., kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.